In this video, we're going to learn how to approach titration-based problems. So our first problem is pretty straightforward. It's if you have a 25 mil sample of HI with an unknown concentration, we need to find that concentration given that it takes 40 mils of 2 molar NaOH to titrate it to the equivalence point. And so if we look at our reaction equation, we have just a 1-to-1 to 1-to-1. I think it's important to understand that in an acid base, a strong acid, strong base titration, really the only thing that's happening is that we're having H plus and OH minus form water. Everything else is just a spectator ion, so you don't really need to worry about the sodium and the iodide. Um, and you could approach this problem using mapping the way that we always have with stoichiometry problems, and we'd find that we could get to our moles of our hydroxide and then our moles of H3O plus or H plus. And from there, we can say that our molarity is equal to our moles over our liters. However, another way of looking at this, since we're talking about the equivalence point by definition is when our moles of hydroxide and our moles of hydronium are equal. We could use a modification of the dilution equation. The dilution equation was M1V1 equals M2V2, and that just meant that the moles of solute before you dilute are equal to the moles of solute after the dilution. Similarly, the moles of H plus are equal to the moles of OH minus based on the molarity times the volume on each side being equal. So substituting in, we can say that our unknown molarity of our acid is times the 25 mils of the acid that we have is equal to the known molarity of the hydroxide times the volume of the hydroxide that it took to complete the titration to the equivalence point. And solving for the molarity of the H plus, we'd get 3.20 molar, and that would be the answer. So our next problem is going to be where we're determining the pH of a solution formed by mixing known quantities of known volumes of acids and bases. So we're not solving for a molarity or a volume of acid or base here. When I see this, I think known amounts of everything, this has to be a limiting reagent problem where we figure out the excess amount of H plus or OH minus, depending on which of those two is in excess. And I need to really stress, we're talking about the acid, the H plus, or the base OH minus concentration that matters the most. It's not the amount of HCl or SrOH2 per se, it's the amount of H plus or OH minus, because those are what are used to figure out the pH. So firstly, let's just get back to our net ionic, our H plus plus the OH minus forming water. So if I have a 0.05 liter solution of H plus and a 0.05 liter solution of OH minus, I need to get to the moles of H plus and OH minus, and I can do it as such. With the H plus, I've got my volume, I've got my molarity of the HCl, and I know that for every mole of HCl, there's 1 mole of H plus. This is because HCl is a strong acid, and I get exactly 1 mole of H plus for every mole of HCl. And so that comes out to 0.00500 molar or moles of H plus. With the OH minus, it's a little bit trickier, right? Because we have a volume, we have a molarity of the strontium hydroxide, but because each mole of strontium hydroxide gives 2 moles of hydroxide, we actually have a 0.0100 molar solution of, or sorry, a 0.0100 mole amount of hydroxide. And so from here, we can say that we have a certain amount of H plus and OH minus, and we can subtract out the moles of H plus because that's smaller. So we use up about half the hydroxide that we have available. And what we find is that no H plus is left over, but there is some hydroxide left over. This is just simply a matter of we have excess hydroxide, we subtract out the moles of H plus, and that's the amount of hydroxide used to get to nothing on the H plus, and we have excess hydroxide. So let's reevaluate where we're at. We're trying to determine the pH of a solution. We know that pH is the log of the concentration of H plus. Right now, we have a mole quantity of OH minus once the reaction is all done. So from here, we're going to say we have moles of hydroxide. If we get to the molarity of hydroxide, we can find the pOH, and then from the pOH, we can get to the pH. That's what we need to do. So let's take our moles of hydroxide that we know, that we just calculated. We're going to go to molarity by taking the moles and dividing by the volume. Now we have to be careful here because we've mixed two solutions, so each solution has a volume. We need to sum the two volumes here and have that be the total volume in the denominator. So we have 0.0050 moles of hydroxide over 100 milliliters will give us a 0.050 molar solution. So we're here now, we're at the concentration of hydroxide. Next, we need to take the negative log of that to find the pOH, which is apparently 1.30. And the last step is going to be to go to the pH, which is simply 14 minus the pOH, which gives us a final answer of 12.70. So I hope this video has been helpful with figuring out how to solve some problems. Feel free to leave any questions or comments in the comments section below, and thanks for watching.